do a little intro. Steve, let's start with you, giving an intro, a little bit of background, and why you are in this webinar. What's your observability story?
Okay, well, I'm Steve Newson. I'm the CTO here at Starling Bank. So I don't think everyone's aware of, certainly outside of the UK, it might be less familiar with Starling Bank as a company. We are what we call a neobank or a challenger bank in the UK. We are one of several that kind of came about in recent years. Basically, the government wanted, the UK government wanted to kind of get more diversity in the banking sector. It was kind of like grown to being, 4 or 5 very large banks that were really kind of ruling the roost. So they changed a lot of the regulation. They changed a lot of they encouraged a lot of things to be able to go and say, well, actually, we should be able to encourage kind of new fintechs to be able to kind of develop and get banking license and be able to do that. We were one of the first people to do that in the UK, and we've been doing that now since 2015. So I've been here since then. So there was about 10 of us in the company at that point. There's myself and the CIO with the first 2 engineers. I'm an engineer by trade. I've always been doing software development in various things. I've worked in banks. I've worked in kind of the public sector to some degree. I've also worked in kind of consultancy and other things. But at the core of that has always been engineering. So coming to Starling was always a huge opportunity for me because I kind of turned up and I was like, well, we haven't got anything here. There's no software. There's nothing. We just have an idea for building a bank and blank slate. It's like, right, let's get building something, right? What was interesting, I think, at that point in time was the priorities at that point were just getting to the point of having a banking license, getting our software up and running, our entire stack going. We didn't really focus so much on the kind of observability, logging, all those kind of things that go around there. It wasn't a concern, mostly because most of the time you're sitting there going, I might not exist in 2 weeks' time. There's no point there's no point getting invested in that, right? Because it could at any point the regulator could say, you know what, you're not going to get a license, at which point that's it, all bets are off. There's no point going anywhere. But I think what happened was we built what a lot of organizations have done in the past, which is kind of used kind of open source, off the shelf technologies to kind of fulfill those requirements. And then it became obvious over time that we needed to be able to find more stable, more reliable systems. We want to be in a position where we're going to say, you know what, logging and observability, the outputs of those things are really important to us. They're clearly, they have to be central to what we're doing. Building the systems to do that and maintaining the systems to do that, it's probably not what we should be doing, right? It's like I should be building a bank, right? I should be building banking systems. I should be providing great systems to customers. If I can find systems that will provide that for me, it's always going to be a huge benefit to me. So that's how I got into this conversation with both Instana and Humio at that point in time. Very close actually at those points, and we've been kind of partnering on various bits and pieces ever since then, I think.
Thanks, Steve.
That's
yeah,
right.
Geeta. Well, tell us a little bit about you and what are you doing in observability, right?
Yeah, I am the CEO of Humio and the co-founder of Humio. We started in 2016, and we have very much been part of this observability conversation, specifically on rethinking logging and how you do it in a way that provides a really scalable, index-free solution. So a lot of our experience comes from consulting prior to Humio. So our 3 co-founders and our team, our executive team, has all sort of been in DevOps use cases where we were essentially developing products for developing them and operating them for third parties, financial and public sector. And so we really got early on involved in finding the value in logging and having that access to your log data. Although we found that we really wanted to rethink the problem in a way that makes it very easily accessible for you to send loads of data, unstructured data, without thinking or worrying about ingest, and finding a really useful query language and a way to get to that data. So underlying is really giving that value to development teams, operations teams, security teams, to get that context as quick as possible. And so we really kind of reinvented what we were thinking from like what we wanted the use case to be for ourselves. So it's sort of like solving your own problem, which is really what we set out to do. And so over the years, we've been building a platform essentially that provides that pillar, an essential pillar in the logging stack and in the observability stack. And then working with partners like Instana closely, as we really realize that companies like Starling are looking for the best of breed solutions for putting together the best observability stack for their particular environments. And so we're very aware of working within the ecosystem of what a company really needs. And this is back to that culture, which I think we'll probably talk about a bit, is it's not just the tools, but it's the culture and building the technology, but also the engineering teams and cultural mindset to have observability built in. So back to what you were saying, Steve, when you realized how you wanted to instrument observability in your company and thinking about that, we're very much part of sort of building that out. So yeah, and thank you for including me in the conversation. Appreciate it.
Thank you for joining us, Geeta. Yeah, a few words on myself. I'm co-founder and CEO of Instana. We are an APM vendor, so we are more on the tracing and metrics side of the observability pillars, and we work closely with Humio on the logging side of the story. And yeah, today we want to talk a little bit about culture, observability, and what that means for companies. And again, I just encourage people to ask questions. But Geeta, you have prepared a few slides, and I like it a lot. And we want to start with one basic question: what is observability? And when we have these meetings here, we always come across this question, and with every meeting, I get a new definition, right? So I think there are a few things that are overlapping always, but I think it would be great to hear from you, maybe Geeta, you starting, and then from Steve and myself, what we think observability is, and then why it's important.
Start off, and so really the way we started this approach is really thinking of observability as understanding, let's say, feeling the hum of your system and understanding what's happening and being able to react upon that information in a timely fashion. So really having this knowledge of what your users, what the systems, what the applications are doing at any point in time. And as we all have, very explicit SLAs and uptime requirements, this is becoming more and more of a requirement rather than a nice to have. And I think from a perspective of where we fit in and we really kind of work with our customers to do is be able to, with a solution like logging and access to all your log data in an interesting and easy fashion, it gives you the ability to get the context around problems. And I think that's one of the biggest things, is that we're all trying to reduce that mean time to resolution. But we're also trying to understand what is normal and what falls outside of normal. So the context behind that is incredibly important when you're trying to observe your system. So I'll leave it at that, and then let maybe both of you sort of jump in terms of how you're seeing observability in your space.
Sure. And then and there's already a question if you can summarize it in 2 sentences. We will try it at the end, right, of this discussion, but I give it to Steve. Steve, you have implemented Instana and Humio as part of your observability story, so I would love to hear what you think observability is and why it's important for you. So
it's fundamentally very important to us. I mean, let's take a few examples. I prefer not to have people having direct access to production systems, right? I think it's a fairly sensible thing to do. And we're in a highly regulated industry. We need to be able to show a good separation between our production systems and our development and engineering culture. However, it's clear that I need to be able to identify where problems are. I need to be able to identify when problems are occurring, when things are going to happen in the future, right? When am I getting? It's not just about what has just happened. I need to be able to go and say what's happening coming up down the line. I need to be able to anticipate that, and I need systems that can kind of highlight to me where to be looking, because I can't have people looking at the entire system all the time, right? So for me, observability in our production systems is being able to give you targeted information about how systems are performing, what's going on in the systems, and where problems may currently be existing, or where it anticipates the system is going to start having faults in the near future. It's all about supporting engineers in being able to do that. The other part about observability is the other side of it, which is that when you inevitably find those problems, when you inevitably kind of say, oh, there's a problem that's going to be happening in an hour's time, or we're reaching a problem right now, we're seeing a high number of errors, I then need a system or a set of systems that allow me to then start digging into that. I need to be able to go retrospectively look at see what was happening at various points prior to this, and pull out data. Now, the ideal thing with observability is to have all of those systems integrated in some way, right? Being able to hop between them and to be fairly seamless between the whole flow. So I should be able to go and say, well, okay, I'm looking at I can see the logs, I can see the transactions that occur, I can see what happened. I can see what impact that had on the system by looking at some kind of performance metrics that are coming out of that, and I can possibly see what the impact is on customers by seeing how what performance they're seeing on their mobile phones or through the website or whatever. So it's really kind of that entire thing. Observability is about seeing all of that and knowing. It's about, some people talk about not monitoring, some people talk about just logging in isolation, but observability is that whole thing to me anyway.
Yeah, thank you. So we already have 4 questions, so I'm trying to integrate them, but I start by adding a few stuff to your answers. For me, one of the questions is, with observability, is always what's the difference to monitoring, right? Because I'm an old monitoring guy, basically, and observability is kind of the new term, so what's the difference? And the way I try to explain is that monitoring is about looking at things that you know about, right? Mm. Like if you know that you want to see the CPU of your host, you want to know, you know that you want to monitor a certain thing, where observability is also about the unknown things, right? Because the systems are getting more and more complex, you don't really know what you want to look at and what the problem could be. And so monitoring kind of lacks there because it really requires you to understand what you want to look at. That's the one thing. And the other thing I like to say is, and I think you both mentioned it's about not only the what, it's about the why, right? Observability is not only about the data, it's also about looking at the data. So, and that comes to the last 2 questions here, I think, and maybe you can jump in. I give my perspective. One is observability about measuring health and performance of a system? I would say yes. It is part of observability, but it's not the only thing you care about, right? There is a lot more than health and performance. And that's one of the things why it's so complex, right? And then how AI is playing to improve observability. And here my answer is that I think that AI is the key part of observability, especially in the near future, because data will become a commodity, in my point of view. So logs, traces, metrics is kind of a commodity thing, and you will be able to store it. And yes, maybe it's better to have it index free, and you will be faster, and you can store more. That's that's a big thing. But on the other hand, I think for our customers, it will become more and more important to understand the why, and as you said, Steve, to predict things, for example. And that's where AI comes into play, right? Finding the needle in the haystack is not anymore a task that's easily done by a human, but we we probably need the support of a machine to help us find the problems and identify things in the data, right? Eliminate the noise and find the real information in that noise. But I leave it also up to you to give your answers to these 2 questions if you have, and then we look at the other ones again.
Yeah, I think I agree. I think there's it's your window into observability is your window into the production system one way or the other, right? And it's about how broad you do that, right? And so what a lot of things, like you talk about metric systems, right? We started out, we were using Prometheus as a metrics scheduler. We still use Prometheus, right? Prometheus actually has some really good things, those metrics and monitoring, and that sits in that monitoring stack. But the definition of that very much is I need, as a programmer, as an engineer, I need to go and tell it what to monitor. It tends to be KPIs of some kind, but it is always reactive. It tends to be, oh, we have a problem over here. Let's start keeping that metric there. Or we're deploying a new feature. I need a metric to do that. But that requires an engineer to think about what those metrics are going to be and what is necessary. And what it tends to end up being is not what's the health of the system, but tends to be more about what the business as a wider business wants for a KPI, which is not what we're trying to achieve here. And there's definitely a benefit there, but it's not what we're trying to achieve here. We're trying to achieve stability of systems and reliability of systems, not the, I mean, obviously it's a secondary goal, but not in order to support, you know, how well is this product doing, or how well is that product doing, or typically that's the case. So we have a tendency to do that. So we've kind of, when you talk about AI being in there, irrespective of whether you just talk about it, you know, how far AI is going on that and machine learning on that thing, it is the best systems are going to be the ones that come around and go and say, I can identify where there are outliers. The statistical analysis of the data that's being passed through those systems is going to be the most useful thing to us. It's certainly we're tending into that direction because there's just too much data. It's getting to the stage now. If you take we spend an active effort to kind of like minimize the amount of logging we put through, minimize the amount of data to try and get rid of the noise in there. But realistically, most organizations are being flooded by logs, they're being flooded by metrics. And that's great because when you want to go and do the diagnosis after the fact, you can then kind of dig through that, and that's why you want it as a diagnostic tool. But when you're seeing it on the fly, you can't process it quick enough. You can't just sit there and go, oh, look, there's an exception. Oh, look, there's an error. There's a problem. You need something to kind of just look at that as a huge kind of an amalgam, basically, of data. So yeah, I totally agree with you. AI is probably the way it's going to go with this.
Yeah, I guess there's a new question around can we observe things that we don't know how to measure? So I guess going back to this point of being able to, understand the unexpected or the unknown unknowns, and really having something that a solution or set of solutions that allow you to find answers to that is fairly critical. And I think being able to ask those ad hoc questions of your system provides a whole new set of capabilities, or let's say power, to those situations where you're running into a problem that is unexpected, and we all run into those problems. It's very, very difficult to set up all of our expectations and all of the metrics and everything perfectly. and how do you go back and try to ask something after it's happened? And I think is the way at least Humio has been thinking about the problem, and a lot of our customers are thinking about the problem of having that that power enabling you to get to what you want. And as you were saying, getting through the noise, getting quickly to the root of the root cause is definitely a big part of that as well. I know we didn't talk so much about observability from a user perspective, but I think that is an area that we see many of our customers use Humio, is to understand how their users are actually using their products. And I think observability in that sense can also have that business view into the systems, as we are essentially oftentimes providing a service, whereas management, et cetera, want to know the usability aspects of how we are servicing our users, what is going wrong, if we're able to support our users. And we have a number of customers that use observability in that realm, and I think it's an interesting angle as well. Because it is really understanding the user. And I think the faster you can get to this data, the better you can actually predict something that may potentially go wrong and avoid a potential support issue. And we found that's been a very relevant case for many of our customers in the thinking around observability and setting that up.
Yeah, Geeta, I have a question, because I know that you are index-free logging solutions, right? I think that plays a little bit into that. Can you shortly explain what that means and what's the difference to a logging solution with an index?
Yeah, so Humio, we sort of rethought the concept of how you ingest data, specifically log data or event data in large volumes. And by setting up a lot of indexes before you send the data in, it essentially inflates the volume. So what we really wanted to do is very little as data is coming in. So Humio is really essentially indexing timestamp. And so that way our data, when it's coming into Humio, comes in at a sub-second ingest latency. So you have access to this data, and then it's streaming in. So we're doing streaming analytics as data is coming in. So that ability to be able to ask questions on the data as it's coming in very quickly gives you this very live feel access into your systems. And this is, again, without doing a lot of structure. I know that, at Starling, there's a lot more work around thinking about logging before it's being sent, but a lot of companies don't have a lot of time to do that or are not thinking about that. And so this is a way where we provide an interesting way where you can just send it all and not worry about, let's say, the ingest phase in the indexing. It's a very different model than other search databases such as Elastic or many databases in general that are, have some level of indexing that is set up in the front. So,
and I think one of the points I want to make is that if you don't know what you want to look at, right?
Exactly.
It's pretty hard to do it if you have indices, right? Because then you basically have to define upfront what should be indexed. And then, for example, to get to the last question, right, the query times can then be pretty bad if you haven't indexed it, but you are searching for something that you didn't know that you want an index on. And so, as far as I understood, that's a big benefit in this new space of index-free things, where you basically are optimized to query on basically everything.
I mean, oftentimes it's also it's like Google search in a way. There's a lot of folks that'll start out with free text search, which makes it a very powerful way to use the query language as well. So it's a very different model in comparison to a lot of the other solutions that are out on the market.
And we get a lot of questions, so I'm trying to push a little bit and try, because I think, let's start backwards. I think, Steve, I think that's a good question for you to also ask how you implemented it in your organization. What's the role of an architect developer to support observability? Is it purely on the DevOps side? I mean, you already talked about the developers, but how do you see observability as part of your teams? And what is their role, right, to make a system observable?
This is quite a multi-layered question that kind of to answer. I would argue that there are different skill sets, right? So there's not, if you have an organization that has architects and solution architects and technical architects and developers, then it becomes harder to identify whose role is what, right? Starling's approach to it is to go, everybody's an engineer, right? There's different skill sets, right? I know that some people are much better at designing bigger systems. Some people are going to do different software things, but realistically, it is everybody's responsibility in order to kind of do that observability. So they need to bake into the systems when they're building them or designing them or deploying them, right? Through whichever role you're in. You need to be baking into your system what the metrics are, the KPI metrics, right, at one end of that monitoring scale we're talking about, but also the observability and everything else, right? I think I don't think of DevOps as actually being probably the one that's worried so much about it. SRE possibly, right, as being if that is a culture in of itself, but that SRE is possibly something you're doing. But realistically, this is all just as an organization, you should be concerned about how you're going to deliver that yourselves, right? How am I going to put those metrics in place? How am I going to know, without access to the system, whether it is actually working or not? And I think that doesn't necessarily go, oh, your role is to do that and your role is not to do that. I feel like everybody's role is to do that to some degree, mostly because the people that are going to be using it are going to be ideally going to be the same groups, or going to be differing groups, right? They're going to be, the architect's going to want to know whether the system that they have built is fulfilling, is able to deal with the number of transactions they want, right? Is it actually able to do that? Is it failing? Is there parts of it that are falling apart because of a design flaw? Whereas a developer, you might be more concerned about, actually, am I seeing exceptions and more kind of granular level information? But it's all the same, it's just on the same scale, really, as far as I'm concerned.
Yeah, absolutely. And then asking directly the question from Juan, I'm not sure, because you're a pretty new bank, right? You're kind of a startup, as you explained. I'm not sure if you have too much legacy systems in-house, but one of the questions here is, what do you do if a system is not designed to be observed and you have legacy systems that you also have to run, right? I mean, that's a really good question. We see a lot with probably more traditional banks or other customers that have a lot of legacy. I'm not sure if you have that situation and what you would respond to that.
We don't have that situation. I've worked in large organizations that do have that problem. Legacy is a bit of an odd one, because legacy, in my mind, is you're creating legacy every single day, right? Every line of code you write could potentially be legacy code in a week, a month, a year, whatever. If you don't do anything, legacy is about maintaining and keeping something healthy and keeping it up to date. It's about applying patches to operating systems, all the way up through moving to more modern hardware, possibly moving through new technologies and taking it on. Legacy happens when you stop doing that, when you stop supporting your systems and you start just kind of tending to them as a kind of like, oh, on an annual basis, we have to take the patch run from the vendor, and we apply that, right? So the problem with those legacy systems often tend to be is that they are closed systems, and I think that it is possible in a lot of cases to be able to get into those closed systems. Some things like, I mean, Instana is a good example. You've got two levels of thing there. You've got the host level monitoring, and you've also got essentially the agent monitoring, which is basically hooking into whatever's running. So if you're running a JVM, inherently you can hook into that JVM, irrespective of whether that system is a legacy JVM, i.e. a very old version of Java, or a modern one. Even at just a host level, having information about the CPU usage, having information about that is very straightforward. Logging is the same thing. There's so many new technologies out there for log shipping, about moving things out of systems. You can take those systems pretty much off the shelf and usually inject them into other legacy systems. Mostly there's some form of Unix variant somewhere along the line, and generally speaking, there's going to be a log shipper somewhere in there that you can bring that in. You don't need to go and say, okay, well, I'm running a very old system, therefore it's impossible for me to do it. It will be harder, I get it, right? If you're using an old Solaris system or using an iSeries AF100 or something like that, you're going to be in a real pickle, right? It's going to be actually quite difficult to do. But I think it is possible. Then there comes the point where you go and say, well, at which point is it more important for me to start? Is the lack of observability actually causing me some negative impact, right? If it's a legacy system that's been running for 20 years, right? If it's like in the UK, we have the CHAPS system, right? But like most of the kind of interbank payment system, high value payment system, most of that stuff was written in the 80s. It's all COBOL was running on mainframes or simulants of mainframes, like, you know, System 36 and kind of all those kind of systems that are in there, right? And all those systems are like, well, they actually, the observability, the window you need into the observability in that is very low because they've been running for so long. All you care about is the outward thing anyway. So you have to kind of weigh that up. If you're going to say, is it worth me getting lots of extra detail in this if it's slowly moving or not moving at all? And if the actual only metric I really care about is how many, is it actually performing? Is it still doing the thing it's supposed to be doing? And that's the balance, right? I think I would always be tempted to go and say, I want to be in a position in this organization, every organization, to be able to go and say, I don't like that anymore. I'm not happy with that thing anymore. I want to replace it. And I think what a lot of large organizations struggle with is they get into a kind of budgetary conversation about saying, well, it's not worth us doing that, so we'll just keep that running for another year or another year. And that's when the kind of rot sets in.
Probably also because they don't have the insights and observability, and so it's a lot of risk to reflect it, right? Because I know, especially for these very old school system, you maybe you don't even have the developers anymore, right? So everybody's scared touching it because nobody really knows what's inside. So yes.
Geeta. One of the organizations I used to work with, who shall remain nameless, one of them used to do. One of the things they did was they used they had a logging system, and they generated vast amounts of logs. I mean, it was a very large system, and it was generating vast amounts of logs. And one of the things that was happening with that was that they built up a culture of engineering, which was like, we want to be able to debug our production system. So what we're going to do is we're going to, every single entry point and exit point of every single method, we're going to put a log message out, and we're going to log at debug level in our production system. Now, the part that we took, one of the questions on here is about noise. It's like, well, that's noise, right? That's like in your logging system. That's not telling you about the health of the system. That's giving you the ability to debug your system, and that's a different requirement, right? I need to be able to go and get that later on, but that's noise for the majority of your observability.
Yeah, I agree. But it also tells you something, right? And that's a question, Geeta, you mentioned it, and I want to get to this question, how to design software for observability, right? And you could go on a high level design, but you also said when you were talking that there are customers like Starling Bank who put some effort into making sure they understand what they will log, and others don't, right? I would call that a design if you put some effort into thinking how you want to observe things and how you want to log. Can you give us a little bit of insights how this looks like?
In a lot of situations, we fall into the strategy that the company is essentially taking. So oftentimes, for example, let's say if it's legacy and moving toward more of a cloud infrastructure and designing that to work as they're moving. We've also seen some large scale deployments that we've been part of, where telemetry teams are becoming more and more visible in companies. So really trying to organize the infrastructure layer under one team, deploying this in a cloud native environment and being able to provide infrastructure services to multiple teams across a large organization and be able to manage that centrally. It's a pretty complex way of designing how to do this, but I'm seeing more and more that you're seeing a head of observability or telemetry that is really kind of taking ownership of how this whole setup is really moving in their organizations. Oftentimes it's movement towards, Kubernetes, containerized environments, cloud native, et cetera, and adopting those technologies from, let's say, a previously more, legacy sort of back end. And we're part of, oftentimes in that process, is in terms of Humio, we can, as you were saying, Steve, we can pull those logs from all those different environments. So I think oftentimes we look at the customer problem and the strategy in terms of how they're designing their next moves and how do we fit in to build that modern infrastructure that they're looking towards moving to. And I think that's one of the areas that we've seen has been useful as, let's say, a particular solution, a logging solution or a metric solution that is specific for one cloud, let's say if it's for AWS or for GCP, et cetera, it confines a company into a certain strategy, right? And oftentimes, we're very much in support of a best of breed type of a platform. So the idea of being able to put anything in and work with any other type of product, as you're saying, there's a lot of ways to bring this data to Humio. So we think about it in that front. I think this is a moving game. I mean, again, back to you said, Steve, it's like, if this isn't working for me, I'm going to replace it. And I think that is where many, many companies are moving. It's like, as soon as this isn't solving my needs, I'm going to need to change that, whether that's a security implementation or a DevOps implementation. We see that quite often moving towards this. So, yeah.
DevOps tends to be that kind of thing. Is a movement in organizations to encourage that to happen, right? It's not the department that runs it. It's just a group of people that are motivated to make that decision. And so the separation of the different roles in there should be, in the ideal situation, should be largely irrelevant, right? It should just be an engineering.
Still, like you said, everyone's an engineer.
It's still not just an engineering problem. It should be a company problem, right? They should be aware that this is that all of these things are important, and not just think about or the IT department keeps moaning about the systems, right? That shouldn't be happening. It should be the engineering. The engineering is part of the company, right? Like everything else.
Yeah, but it's always, I mean, I was an engineer for a long time, right? And I remember, for example, let's take a very simple example, right? If you are logging, you normally have something like a log level, right? Which is a very simple semantics, like warning, debug, error.
Yeah.
But the experience I had is like people log errors, then you find an error, and for example, we as a APM vendor, we say, hey, there's an error. Then the developer comes says, yeah, but that's not a real error, right? It's like it is an error, but not a real error, right? So I think there is some kind of design needed and some rules to make sure that if you have a form of semantics, and this could be tags that you apply, this could be the log level, this could be a trace ID or a starting point of a trace. So how would you, and especially if you have these distributed, self-organized teams, I would be curious, Steve, if you have any form of kind of like guidelines, or is it how do you organize that you have kind of a structure, or maybe you even say, I don't care because every team is responsible for it, and so they have to make sure it makes sense. Right?
Yeah. The line that I hear, so I've heard so many times in the past is, oh yeah, that's an exception we see all the time.
Yeah, right.
And it's not an exception. It's not an exception. If it happens all the time, that's normal behavior of your system.
Yeah.
And at which point you need to make either decision you're going to get rid of that log message because it's not telling you anything, or actually do something about it and fix the underlying problem. We've been through a lot of iterations on this and a lot of conversations about what we should do. And when I want to clarify a little bit about the conversation about like kind of gardening, right? So doing all the kind of the making sure that the logs that we're shipping are the right logs, right? There's two factors. Right? Yes, I can dump the whole lot. I could just literally just pump everything at Humio, and the same thing as in Instana. I could just pump data out there and let you filter it, right? But but that actually encourages a behavior which is going in a direction where it's like I don't care about my logging, right? It's like you should care about your logging. You should care about your monitoring. You should care about what you are shipping to those things. As teams in our organization, we try to encourage that behavior, right? It's like, and one of the ways we do it is like we have a channel. We use Slack, and we have a channel in Slack which is just exceptions, right? As soon as an exception pops up in the logs, I will get a notification in Slack, right? And we also do things where we go and look for constant repeats of those same exceptions, and we say we're actually seeing an uptick in those exceptions. I can get that from Instana and get that from monitoring, but it's about putting it in someone's face, right? And saying, look, actually, this very raw metric is really important, right? There's a raw metric which is saying what's doing. So you can combine all those things together to kind of do that. And then we encourage basically to say, well, if you're getting an error in the system, you have to make a decision. Is that error, do we need to run an instant, right? Is this actually a problem for the bank, or is it not a problem for the bank? If it's not a problem for the bank, it should never have been an error or an exception. In the ideal situation is you build systems then and go and say, okay, I've got a choice. I can either get rid of that or just say, it's not worry about it, let's get rid of it altogether. Or I have to make a code change to the system in order to rectify that, either by healing itself, right? Like you get a null pointer exception, right? Okay, I need to put some code change in there to go and find out why that has happened and to rectify it anyway. Yeah. So that's about having an engineering team that feels like, firstly, that they can deploy into production whenever they want, and that they can do what we don't classify things as being technical debt. We don't go and say, oh, that's a low priority bug, right? That's not a low priority. It's either an incident or it's not, right? There's no little ground in between there. If you treat that way, then you can get into a much more kind of healthy situation. But like I say, in large organizations, we're hugely lucky, right? Because we're able to set this up from scratch. Yeah. In large organizations, they are more likely, and this is the challenge I know a lot of people on this will be having, they're more likely to be having pushback, saying, no, we don't need to fix that. That's technical debt. We'll do that at some point in the future. And that's where you end up with the noise, right? You end up with just lots and lots of exceptions. I used to work in an organization, another one, Charles knows, they had no logging. Geeta would hate this idea, right? This is a terrible thing, right? No logging throughout their entire system. They ran their entire production system. The only thing they had was they got an exception, it poked an exception out, and they treated that exception immediately as an incident, and they would make sure everybody get together. Like it was a relatively small engineering team, like 20 other engineers. Everyone would get together, do the change for that thing, get it fixed, get that deployed in production, and that would be it, right? And that would be on. So they were always aiming for no logs in their production system, which is almost unachievable in most industries. But it's kind of an interesting way of going back, and I think there's a middle ground that we need to kind of achieve.
Absolutely, absolutely. And I like the emphasis you are making on both sides, right? Even in the past, that it's kind of a cultural thing, right? You have to have some values, and you have to create a culture around it so that you make sure that people feel responsible, right? I totally agree with you. If people just put everything somewhere, right, they don't care anymore. And that's not a culture that will help you build a good observable system. But if you make sure, in this extreme case where you only have the exceptions, right, then people will really care, right? Because this is the only information, everybody will be aware of it, and you will look at it.
Yeah.
I come to a question.
Sorry, I was going to say, I think as an architect, or in that kind of senior level within an organization, it's responsibility to bring the engineering team on board with that. The other thing that I found often is the case is that you end up with this kind of senior person golf day thing, right? Where you end up with a senior person in the organization goes on a golf day with some sales executive, one of the very big organizations out there, and then comes back and says, "It's all right, I've solved all your problems. I bought this fantastic product for you. You can just implement that." That'd be great.
I don't play golf. That's a problem.
Golf lessons, Mirko.
It's really important to bring everyone along with that and the journey, and understand what all this, everything is done in this. Right? What are people? What do you need out of your systems? What observers you need as engineers, and how are you going to go and say, how are you going to build a better environment? And that also means going and saying it is acceptable for your engineering team to spend a degree of their time just tending to their production systems, and not go, well, we need a project for that, or we need to deliver something on this. So, like, you're going to be in that position.
There was a question before, which was around the KPIs, which I would be interested in hearing from you too, Steve, and maybe also your experience, Geeta. We see a lot that people adopt more and more the concept of SLI, SLOs, and error budgets to basically put all the things on a higher level, right? On real, probably even business KPIs, right? I don't know how many banking transactions I have per day, or how many users log into my online banking. So basically on a very high level, because you already have so many data and metrics and things that you kind of have to aggregate these to a higher level metric, which makes more sense also to the business, right? Mm-hmm. So are you seeing that too, that you get more requests on making it more on a higher level KPI, SLI, SLO level, or?
Yeah, I think what we've been seeing, I guess we have this concept of management dashboards where essentially they can be instrumented and then sent out to management, so they're not mucking around and querying, but they're getting, let's say, a management KPI dashboard, the golf course dashboard, right? Which is sort of, around, let's say, understanding the observability of the system. And oftentimes they are engineers, but, again, they're probably not writing code or managing the systems, but they still want to know what the state is. And this capability to provide sort of a real-time view into that is nice. I think for ourselves, we've been looking at things like, for the engineering organization, like DORA metrics and other things that are being developed out of, the work that Jean Kim and Nicole and Jazz have done, to sort of also look at sort of KPIs for our internal organizations as well. And I think, those are also, I think, relevant for a lot of engineering organizations to be looking at in terms of managing, how well their engineers are performing, or the product or the teams are performing. But yeah, KPIs can be taken in all sorts of ways with, if you have access to this data, the business side, we haven't really gone into BI, but the data exists. And in some ways it needs to be, let's say, a golf course like a view. And if they can look into that, it's available, but it's really putting that towards a whole new sort of user. And we feel there's a whole heck of a lot of business in where we are today that I think we're covering a lot of our team's worries and focus around the engineering and the IT ops and security side. So, but it is an area that is, interesting. So I would say that's how we provide it. But we found that sometimes an engineer and an access to Humio in a management meeting can can end up being lots of questions, and the engineer is asking all sorts of questions of the system as it's going. We've also seen companies do things like retrospectives and other things. So I was curious to ask Steve in terms of also like, different ways that you're using observability, let's say on the development cycles, for example, when you're developing software, pre-production, et cetera. What are you looking at from an observability perspective there? Curious as to how you're using it and your teams have been using it.
Well, it boils down to the same thing, which is we don't have a separation between production support and developers. Engineers. I don't have.
I was looking forward to you saying that. I was looking forward to you answering it in that way. So
John's the CIO. John and I have worked together on and off in various places for a very long time. Both of us are engineers, and we both have seen things that we viewed as being inefficient or bad or kind of that make problems. And one of those ones was this concept of having kind of, particularly in banking, this concept of having an engineering team delivering stuff and then having a group of people that are supporting that thing, and then the people and all these different layers, and everything passes across. It's usually through ticketing systems. There's usually that somewhere in there there'll be a Jira with thousands upon thousands of tickets or something equivalent to that. Mm-hmm. And the part of the problem with that is that you've separated the people that are causing the problem and the people that are experiencing the problem, right? And so it is very easy for you to go and say, I'm going to go to write some code, and then you forget about it. Long development cycles, long release cycles, they cause the same sort of thing, right? They just mean that the person that wrote the code doesn't immediately feel that problem. As soon as you bring the responsibility of that code, of that software, or whatever the infrastructure, whatever it is, closer to the people that are developing it, they become much more aware of what's going on. It's fantastic working in I have to say, it's fantastic working in a bank, because one of the things that, which I don't think people certainly wouldn't have said during the financial crisis, but it generally is, because it's one of those things where you work on a product where you use it yourself, right? I am a customer of Starling Bank, and I'm proud. I've been since right as soon as we got our license. That's what I did, right? And I was like, I'm moving across to it, and I moved all my banking across to it. And what is fantastic about that is you get a very close relationship with the product you're selling, right? So I go out there and I go and say, right, I'm going to go and use a card transaction. I get that feeling. I wrote some of the code, or a large portion of the code that did that card transaction. If it fails, it's my fault, right? Yeah. And that's an amazing feeling. If you can make your organization think the same way about production systems in the organization, you can get that same behavior, right? It's like I feel upset that my system is not working. I feel annoyed that I got woke up in the middle of the night because my system failed for some reason. Yeah. If it's somebody else that's doing that, it's a real problem, right? That close-knit is really important.
Yeah, it makes sense. We have another question here, and that's around AIOps. And I like that question a lot, because I think AIOps is a really interesting topic. And I would just start giving you my perspective on it, and then would like to hear yours. So I think, as I said, that AI and looking at the data with the machine is really what will be the future of observability, my point of view. And the way I think about it is like autopilot for your DevOps teams, right? I think what in the future will be important is that observability systems help you auto-remediate, auto-fix issues in production without an engineer needed to touch it, right? So, because one of the problems, Steve, I think you will also see is that if you have the team that develops code responsible for production, if you have 24/7, it's always an issue: who's on call, who fixes an issue at 3 a.m. in the morning. And that's something I think a machine can really help, especially in modern systems where you basically probably also restart a container or do something. I think that on a majority of the issues, we can make sure that while a team is available for 8-9 hours a day, the rest of these hours, a majority of the issues can be handled by the machine. And then only in the real critical issues, we have to wake up an engineer or get somebody on call. So I think like this autopilot idea is what I see as one of the things where we can really help organizations to focus on development and make sure that I would say the easy things are fixed by an AIOps solution. And why do you need Humio and Instana? I think because you need the data to really figure these issues out and learn from that data and learn what's going on and understand the context and the semantics. And that's where tools like Humio or Instana can help, right? And I don't know. I think I'm pretty excited about AIOps and the possibilities that we will have, and how we can support users in focusing on the job they really care, right? Because nobody loves on call, right? I have never found someone who says, yeah, I love it, right? At 3 a.m. in the morning, restarting a container, that's fun, right? I think that's where we can really help.
Yeah, I agree. Having it fed back into various other systems. I mean, we're a cloud-based, we're AWS primarily. We do have physical infrastructure. We have to because of various schemes we need to talk to, but it's very little. It's very light touch in terms of where we can. We try to minimize it. But one of the things is that cloud-based infrastructure it has made it so that you can do more health checking, you can do more evaluate system-based understanding. So you can do, first things is your systems can report their own health out, and you can respond to that very easily. You talk about containers, killing containers. It's like, well, if the system knows it's reporting itself unhealthily, it's like, well, the system knows what to do in that situation. Clearly, you don't want to get completely out of control and just starts killing things left, right, center. But then, actually, that's not a problem. But then the other thing is we're in a luxurious position in that we are able to kind of evolve an infrastructure that's a bit more self-healing and understands. It has tolerance to failure, right? And baking that in at the outset and saying things are going to go wrong, and I'm happy for them to go wrong, right? You cannot get 100% uptime. It comes back to that SLI, SLO. It's like what is our tolerance? But what is the tolerance for failure in this system, and how do we recover when we inevitably see that failure? Chaos engineering is a fantastic thing that's going to be coming out. Is really getting in there, and I think. Financial institutions are less willing to take that because they are under this illusion that systems should be up 100% of the time, and why would you expect it to be anything less? Yeah. And that then means they're less able to deal with the situation when it's not up for that full time.
But are you using chaos engineering techniques already?
Yeah, not to the level I'd love to. Right, we definitely are. We have a system running in production, Chaos Monkey running in production, which is just switching boxes off left, right, and center, and it does that with on a random basis. We kind of trigger logs to say when that is. We can see the correlation between that happening and any subsequent errors or exceptions that we see, and we can then trace them back. It's quite a nice thing to have that all kind of linked together. But yeah, we definitely use a little bit of that. I would love it if we could do things like simulating network problems, kind of high latency in certain areas, all the kind of things you get, CPU spikes on boxes, that kind of stuff. And that would be, once we get to that kind of level, that's a fantastic level. And I expect that our systems that are kind of monitoring that would pick that up and then respond automatically. My ideal situation is I get a spiking CPU on one particular box, or it's running out of space, or in a kind of very simple metrics, right? Starts doing that, and it's like, fine, my monitoring system or observability system is actually going to sit there and go and say, I know what to do in that situation. I'm happy to just get rid of that, right?
Yeah.
Yeah, that makes sense. I always have the feeling that chaos engineering is on I would say, cloud native maturity level. It's pretty high. Like it's probably level 5, right, to get there and to really be able to do that.
We are not there yet. We are not there yet. I would love to be there. But we are not there yet.
Yeah. I mean, interesting in for our customer base, a lot of this automation and work outside of Humio, or the data-driven sort of automated work, is actually happening in the security side, and they've got a lot more need to act quickly and have rule sets, etc. So one of the areas that we do quite a bit is integrating into essentially these SOARs or automated response, and similarly these types of ways that you can use this data to trigger so many things. And this is back to where we see the world going. We're seeing also with machine learning and other models, that companies are building that on top of Humio, very specific to their own environment. Because again, back to these models, they are oftentimes specific to the use case, right? And so defining what is it, back to what is it you're trying to do with the machine learning, and not just, let's say, off the shelf pulling something down and using that. So we're moving towards that in our product as well, and supporting those models. So yeah.
Thank you. I see that we are almost at the top of the hour. It always goes so quick, right? We only used one slide. I have to say thank you to the audience for giving us so many good questions. Steve, Geeta, it was a pleasure having that webinar with you. Thanks for giving these great answers and your insights into how you do observability and development. I think we could talk for another hour, but I guess it was great starting here. And I'm not sure if there's any other question for the last minute, but I say thank you. And hope that we do this again.
Yeah,
excellent.
Great. Thanks a lot. It was a pleasure.
Thanks, everyone. Have a good day and see you next time in the webinar.
Bye-bye.
Bye-bye.